Good evening, everyone. Dr. Chanchala Jain, ma'am.
Good evening, sir. Yes, sir.
Yeah. Start the session, ma'am.
Okay, sir. Good evening, everyone.
Good evening, ma'am.
Good evening, ma'am.
Good evening, sir. Good evening, ma'am. So, shall we start?
Yes, please.
Yeah. Give me a second. I'm just opening my slides.
Ma'am, if you could just give, as you're opening your slide, just when you begin, 5 minutes for question answer and then start, if that's okay, from yesterday's session.
Okay.
Shall I ask a question now?
Yeah.
Okay, so ma'am, I have actually got SPSS version 26, and you taught importing the data yesterday. So from the file, I made Excel file and I imported the data. So that has happened, and I'm looking forward to learn today how do I, do analysis from that. So I hope I'm to set the expectation from today's session. Yeah.
Sir, I think expectation can be set by anyone. I'll try to fulfill the expectation. There is no problem.
Sure, ma'am. Thank you very much.
Okay. Any other question you are having?
No, ma'am, actually, I will be asking more from my, since I'm actually practicing, I'm actually in the process of my thesis. So my questions will be more real situation of real data, etc. So that could be, I may ask you questions around that. That's it. Thank you.
Fine, fine. Okay. So, shall I start?
Yes, please, ma'am. Sure.
Yeah.
Good evening, ma'am.
Yes. Good evening, ma'am.
Ma'am, actually, I have a problem. I tried to download the SPSS,
Okay.
but it was downloaded, and but it is not going ahead after signing.
Means I'm not getting. After signing means?
साइन इन हो रहा है बट उसके बाद मतलब कोई विंडोज नहीं आ रही एसपीएसएस मैंने फोटो भी उसका क्लिक करके ना डाला हुआ है व्हाट्सएप पे
Ma'am, have you gone on IBM SPSS web page?
yes
Have you
from
created
IBM
your account?
yes ma'am
After creation your account, you have downloaded the SPSS.
yes ma'am
Have you installed?
yes ma'am
So can you show your screen?
okay ma'am
Okay. So Jyoti, may you please share your screen?
yes ma'am wait
Yeah. Jyoti, ma'am, I think we are waiting.
Yes, good evening, ma'am. I have also faced the same problem after downloading this version. Is the problem which have been said by the Jyoti ma'am. Can you tell me the solution of that problem?
I think it's difficult to tell you the solution because I think going on a website, you need to only create your account, and that way it is allowing you
Yes,
to
ma'am,
download.
account is created and we have received I have received the Gmail ID from IBM side that what is your ID and password. But after that, when we log in the trial version, yes, the same screen is shared by ma'am. Yes. log into the IBM.
Ma'am, can you see my screen?
I think no, nothing is visible to me. I think only I can see some screen, but there is nothing like your window or nothing I can see.
Ma'am, now it is visible.
I think only the Google Meet I can see. Browser I can see only.
Ma'am, now it is visible.
As I said, I think only the browser I can see, ma'am. Apart from that, nothing is visible to me, and I think for others also.
मैम व्हाट्सएप पे मैंने डाली हुई है स्क्रीन, आप वहां पे देख सकते हो
But
कि कैसे
ma'am,
शो रहा है.
I think it is difficult for us. I need to wind up this session also. It's almost 10 minutes late.
Okay,
So
ma'am, you
I
can start.
think, give me a second. I'm sharing you one video. You people can see that, and that way you can download it. So on our group, I have shared as link. Probably this can help you to download. Fine. So meanwhile, I hope I can start the session.
Yes, ma'am, please.
Yeah. Okay, I think I shared the slide presentation. I hope it is visible to everyone.
Yes, ma'am.
Fine. So day 2, we are talking about the reliability and the normality using testing or checking using the SPSS. So agenda of the day is I am going to talk about what is reliability, what are the types of reliability, what is normality, and methods of checking the normality of the data. This is the agenda which is I am going to cover today. Talking about firstly the term reliability. Give me a second here. So firstly, we will talk about reliability. Generally, when we say reliability, give me a second. Yeah. So I am discussing the reliability on the these 4 different quadrants. The first thing is what is reliability? Reliability meaning is that it is nothing but we are measuring the consistency. Then question comes consistency of what? Consistency of your scale. Scale meaning is your questionnaire or instrument. Means whatever questionnaire or instrument you have prepared, you need to check whether the questionnaire is reliable or not, whether the questionnaire is consistent or not. Consistent meaning is that it should produce the same results again and again when you are conducting a same scale or when you are using the same questionnaire on the different population or on the different samples, right? So this way, this is known as the reliability of the scale. Second question is when to check the reliability of your scale. So whenever you are having the Likert scale variable or non-Likert scale variable, in both the cases, the reliability can be checked. Means if your items, means your questions or statements are on a Likert scale or maybe it is on non-Likert scale, even in both the cases, we can check the reliability. Now, where this reliability is implicable or applicable, so that way Generally, many a time it happens we are taking the scales or the questionnaire of the other authors which have already used, means the people who, those who have already used certain questionnaire or scales. Generally we are picking those questionnaire for our own research. So whether you are using the existing scale or you are creating your own questionnaire or your own scale, in both the cases it is always recommended that you need to check the reliability of your skills, right? So question comes, why to check the reliability of already set or already checked scale? Because scale is developed, so in the development process already the reliability is generally checked by the previous authors, and also they are validating that type of skills. The question comes, why we are checking it? So the answer is very simple. When you are using the scale of other person, might be your context can be different, your population or your sample will be different, your reason will be different. So there are many things, even the time period is different. So that way it is suggestive, whenever you are using the existing scale, even in that case also you need to check the reliability of your scale, whether your skill is consistent or not. Question comes, how to check the reliability? So reliability can be checked using the various methods. So there are certain methods available, using that we can check the reliability of the skill. I hope till here I am clear to everyone.
Yes, ma'am.
So may I proceed further?
Yes, please.
Yeah. So now in this next slide, I'm talking about the types of reliability, and we will see the methods further. So when I say types of reliability, generally reliability can be classified into the two parts, stability and the internal consistency. Stability, I think I just explained you, means when we are checking the consistency of our scale, whether the over a period of time the scale is generating the same result or will generate the same result or not. For the purpose we need to check the reliability of the scale. Internal consistency, which is mostly used nowadays, is what means whatever number of items you are taking on your scale. Items means the number of questions which you are taking on your scale. So you need to check whether the items which you are taking on a scale, they are internally consistent, they are internally related to each other or not. So this is what you need to check in the internal consistency, because generally we are making a scale for measuring a same kind of variable, right? So same kind of variable meaning is, so when we talk about the scale, or means when we are talking about the construct meaning is that, say for example I want to measure the satisfaction. So we know this thing, satisfaction is a thing which cannot be measured using any particular unit at all. So that way you need to frame certain number of questions. So satisfaction will be depending what type of satisfaction you are measuring, whether you are measuring whether you are measuring the satisfaction of the person for the particular product or services. So that way you need to find how many things are generally are what I can say, how many things are generally um, what I can say, that helping you to understand that these things or these particular dimensions of factors can be possible, which can be making a particular person satisfied. So on each type of dimensions of factors, generally we are asking the questions from the people. So that way you need to check. So for satisfaction, n number of questions you can make in your questionnaire, and all the questions of that questionnaire should be internally consistent, means they should have certain relationship among them. So this is known as internal consistency. Now talking about methods of reliability. So generally when we say the types of methods which we are using for the reliability, so there is test retest reliability, there is parallel form reliability, split half reliability, and the internal consistency reliability. So these are the four methods available, using that we can measure the reliability. First two, which is test retest reliability and the parallel form reliability, these two are coming under the stability, means using these two methods we are testing the stability of the questionnaire. Remaining two, that is split half and internal consistency, generally for using to measure whether the items are internally consistent or not. So we will understand all four methods one by one. Firstly, I'll take the test retest reliability. So you can see on a slide, I am showing you so many things which are written there on a slide. These all the things are the theoretical thing, right? So I tried to convert this theory thing in the diagram form to make you the better understanding of test retest reliability. So that you can see here. I hope the screen is visible to everyone.
Yes, ma'am.
Okay, give me a second. Now, so when I say test retest reliability, here you need to see test meaning is your questionnaire or your scale, right? So this questionnaire or scale which you are using for testing the reliability, what you are doing, you are having the group of people. You are giving your questionnaire to the group of people and asking them to give the or to give their responses to the questions of that scale. And then for the same group of people, you are again conducting the same test. Means you are circulating the questionnaire to the same people, same group of people twice. But the thing is that there will be certain number of certain period of gap. There should be approximately a sufficient gap should be there, so that that way you are understanding whether the people are now means whatever questions you have asked previously, same type of opinion people is having again for the after a particular time period or not. So that way you are collecting their scores twice on a particular time interval, and you are collecting these scores and you are checking or you are measuring the correlation in those scores. If correlation value is coming zero point 0.7 or more than zero point 0.7, that way you can ascertain or declare this thing that the scale is the reliable scale according to the test retest reliability, right? So test retest meaning is you are testing or test and retest meaning is you are circulating your scale twice, but with a particular period gap, right? Second one is second one is the parallel forms reliability. So parallel forms reliability, again theoretical part I am omitting, and I'll talk about the diagram which I have made here. You can check here parallel form reliability. There we will be having a questionnaire or scale or test. And now what you need to do, you are dividing your questionnaire or scale into the two parts. Suppose you are having a questionnaire or a scale in which there are suppose 30 questions, right? So you are dividing that particular scale into the two parts, like 15 questions and 15 questions. Fine. And that way you are giving the 15 question to the group of people, and in a small or in a short time frame you are again conducting a test, but in this time you are giving the second part of questionnaire to the same group of people, and that way you are collecting the scores of the people. And in the scores you need to find the coefficient of correlation or the correlation value, and if this correlation value is zero point 0.7 or more than zero point 0.7, that way you can ascertain that your scale or your questionnaire is the reliable questionnaire according to the parallel forms reliability. So this is the second method of testing the reliability. Talking about the third method, which is the split half reliability. The split half reliability meaning is that you are, rather than dividing your scale into the two parts, this time you are dividing the group of people into the two parts. Your scale will remain same, means same test you are using, but you are dividing your group of people into the two groups, group 1 and group 2, and you are giving your test to both the groups at the same time period. Means on at a same time period, suppose there are 100 respondents, so for 50 respondents you are making them sitting at a place, you are giving them a particular test to them, and on a same time remaining 50 people will be on the other place, and they are facing or they are giving response to the same question, and that way you are collecting their scores and you are finding the coefficient of correlation between those scores. And again, if the correlation value is 0 0.7 or more than 0 0.7, so you are saying that your scale is a reliable scale according to the split half reliability. So this was the third method of testing the reliability of your scale. Now, the most important method which we are talking now is the internal consistency. So I think I already told you the meaning of internal consistency. In the internal consistency reliability method, you need to check whether your items or your questions which are there on a scale or on an instrument or on a questionnaire are internally consistent, or they are having certain relationship or not. So generally internal consistency comes when we are measuring a single variable, and for single variable we are taking so many questions. As I have given you the example of satisfaction, maybe the brand loyalty, maybe the perception, attitude, etc. So for such kind of latent variables, or for such kind of construct which cannot be directly measured, or we are not having any particular units or instruments to measure them, generally we are asking certain number of questions to measure the same thing. So in those questions or in those items, there should be some relationship existing, and this is the way, or this way we can say this is the method which is internal consistency, which is helping us to find that internal consistency among the items, right? So to make you this more clear, I have taken one example. Suppose we are having, we want to measure the satisfaction in persons, right? So to measure the satisfaction in person, ask any one of you, are you motivated or not? So I think person can express yes or no, but when I say I want to measure it, we know this thing, it is very difficult to measure the motivation level in a person, right? So suppose to measure this, we have taken certain number of questions. So meaning is that your motivation is your construct variable, right? Or your latent variable, which you need to measure. For measuring this, you need to take certain number of questions. These questions can be, you can give other names to this thing, that is indicators, dimensions, items, questions, variables, whatever name you are giving. These are the number of questions or statements available with you. So now, with the help of internal consistency, we need to measure the correlation among these all 10 items. If you are finding a fair correlation among all 10 items, you can say this thing, that your variable, that is what I can say, your scale is the motivational scale is the internally consistent. So this is the meaning of internal consistency. Now, when we talk about internal consistency further, so maybe I think many of you have already heard the term Cronbach's alpha. Cronbach's alpha is very popular measure for measuring the internal consistency, reliability of a particular scale. This Cronbach alpha is mostly used nowadays. I think when I discussed today about the reliability, I also discussed the Cronbach's alpha, because generally we are making a scale which is generally measuring a single construct. So that means all the items will be related. So we need to check whether the items are internally consistent or not. So using the Cronbach's alpha, we will check that. Further, the Cronbach's alpha was given by the Lee Cronbach. So after his name, this particular coefficient was named as Cronbach's alpha. As I said, it is a measure of measuring the internal consistency or inter-item reliability or inter-item consistency, right? So this is a coefficient. Using this coefficient, you can measure whether the items are internally consistent or not. So generally, we know this thing, when we are measuring a construct, we are taking certain number of questions, and questions are generally on a Likert scale or all. So this Cronbach's alpha can be used for the continuous scale variable also, and for the dichotomous scale variable also. Whether means dichotomous meaning is when you are having the responses like yes, no, true, false, right, wrong, correct, incorrect. That is dichotomous, when you are having only two options. So for such kind of questions also, you can check the reliability of the scale, right? Further, formula, if I talk about, these are the manual processes to check the reliability using the Cronbach's alpha. There are two methods, variance method and the correlation method. So these formulas are generally used to get the alpha value, but I think we are using a software. So we will not go in this nitty-gritty, and we will not see that how you can measure this alpha manually, because we are having software to measure that. Now, the most important thing is that interpretation of convex alpha, how you will interpreting the convex alpha. So for interpreting convex alpha, you can see this is a table available. I will explain this table from the bottom. I'll come from bottom to up, right? So you need to see the last row of this table, which is saying alpha is less than 0.5. That means when your alpha value is less than 0.5, you are saying this thing that the reliability is unacceptable. You cannot accept the reliability of the scale. When alpha is lies between 0.5 and 0.6, you can call it as a poor reliability. Between 0.6 and 0.7, it is known as questionable reliability. 0.7 and 0.8, acceptable reliability. 0.8 and 0.9 is a good reliability. Means above 0.7, it is an indication that your scale is acceptable, or the reliability of your scale can be accepted. Then question comes here when I talk about the top row of this table. You can see alpha is greater than and equals to 0.9, which is the excellent reliability. So excellent reliability is coming when the alpha value is greater than 0.99. But the problem with this is that when the alpha value is very large meaning it is suppose 0.98, 0.95 something, this is an indication that there is a problem of multi-collinearity in your scale. Multi-collinearity meaning is that two items are almost identical, right? So for example, if I say two items are, because we know this thing, a correlation will be, means suppose I am measuring the correlation of the same variable, means suppose there is a variable called x. So when I'm measuring the correlation, I need to have two variables. So suppose I'm measuring the correlation of x variable with x variable. With the means with the same variable I'm measuring the correlation, it will always come 1. That means if you are having the two questions and the alpha value is coming more than 0.9, this means it is indicating these two items are almost identical, or people are taking it as very similar, right? So in that case, you need to decide upon which two items or more than two items, whatever number of pairs are similar. You need to check. If you are finding this kind of thing, you need to check which item you can drop from your skill. So you, by the opinion of your opinion of your guide, or maybe expert, or maybe the senior faculty members of your institute and all, that way you can decide upon which question you need to drop and which question you need to keep retain in your skill. That way you can bring down the convex alpha value, and that way it will be good sign, because more than 0.9 is a multicollinearity, because it is a symbol of identification of the items, right? So this way you can check the Cronbach alpha value and you can interpret the alpha. Further, how to check Cronbach alpha, I think method I'll show you when we will go to the SPSS. Now we will talk about the most important thing, which is the improvement in the reliability coefficient. That means if suppose your alpha value is coming nearby 0.7, but it is not exactly 0.7, right? So because problem is that according to the literature, generally it is the notion that Cronbach alpha should be around 0.7. That way you are ascertaining or saying this thing that your skill is a reliable skill. So if it is not, because I think we have done lots of efforts in collecting the data and all, so maybe means we need to identify, or we need to find the ways that how we can improve the Cronbach alpha. So the ways are here. First thing is you need to you need to see a removal of the ambiguous or the redundant items. Means when the items or the questions are very similar or ambiguous in nature. Ambiguous meaning is the double meaning questions. Maybe you have asked the question from some other point of view. People may can take that question from some other point of view. So that way there is a problem with that. So always you need to see very carefully what items you are putting, whether the items are very clear and concise or not. You need to discuss with the experts of the field, or the senior faculty members of the department or the organization, or from some other institute, and that way you need to decide upon which items should be there on your scale. That way it will help you to improve your Cronbach's alpha value. Second is diagnose the missing values. Missing values means if suppose any of the question is unanswered. It is like many of the people have not given or responded to any particular question. So that will be a problem again. This will again lead to the bad Cronbach alpha value. So you need to check if any question is having so many missing values. So you need to decide upon whether you are dropping it or whether again you are approaching to your respondent to respond that question. That way you need to do this exercise. Last thing is that diagnose item total correlation. So item total correlation, I think this is the output of the reliability. There you will get a table. In that table we will be having this value, and using this value we need to see whether using that value can we improve the Cronbach alpha or not. So how you can improve? So there are generally, first thing is that this item total correlation should not be negative. If for any item this value is coming negative, firstly you will drop that item from your scale, and then again you will apply the Cronbach alpha process and you will check whether there is any improvement in Cronbach alpha or not. After removing all the negative item total correlation value, if it's still it is not coming up to the mark, so in that case you need to check whatever are the very small values of item total correlation. One by one you will drop those values, right? So up to 0.2 or up to 0.3
యుద్ధం
is,
చేస్తుండేడు బ్యాగులతో, యుద్ధం చేస్తుండేడు బ్యాగులతో.
so if your Cronbach alpha is if item total correlation is 0.2 or 2.2, till that point you can drop those number of items to improve your Cronbach alpha value. So firstly you need to give, or you need to drop the items or the questions which are having the negative item total correlation. Then you will proceed from negative to then 0, 0.1, 0.2, something like that you need to check. And that way you need to make a balance how many questions you can remove to achieve a fair or the acceptable Cronbach alpha value. That will be the decision of the researcher. So this way, these are the three methods. Using these methods, we can improve the Cronbach alpha. Further, I need to discuss the normality. So I think I'll discuss normality afterwards. Firstly, whatever concepts we have understood about the Cronbach alpha, about the reliability, we will apply those questions, and then we will see how we can check the normality. From here till here, I think I'm okay and clear to everyone. Any doubt?
Yes, ma'am.
Ma'am, one question I have. You mentioned about test retest. Now, in that, in the test you said the sample question which was given and the original question, they can be taken as test retest.
Sorry?
In your test retest example, suppose we have taken a pilot study and then we have taken a main study. So they can be taken as test retest.
I'm not getting, in a pilot study you are saying, or in a main study you are saying?
I'm saying that in the test retest, you said that we have to take the question once and then we have to take it again. So can we take the pilot study and then the main study as test retest? In the test retest methodology, can we take that approach?
I don't think so. It is a good approach, sir. According to me, means I am not sure about the other person, because after pilot study, we are doing pilot study for checking the reliability only. So if you are spending this much time in the pilot study, so that will be a problem, because in the pilot study, if you are understanding your scale reliability is not good, that means that is a sign you need to make changes in your skill, right? So you will make certain changes to, you will improve maybe the formation of your statements, or maybe you're introducing more questions, whatever it is, whatever is suggested by your experts of the field, or maybe from your guide. That way you will incorporate the changes. And after incorporating of the changes, again you will conduct the pilot study for checking the reliability, right? So you need to go to check the reliability using the Cronbach alpha. But again the question comes, when I say because as I said, Cronbach alpha or the internal consistency reliability is the most demanding nowadays, and most of the people are generally reporting this reliability, right? So when you're talking about test retest, it is mentioned you need to take a long time period gap, right? Long time period gap meaning is, suppose you have done your pilot study today, Suppose it is a January month, right? So almost 5-6 months or 3-4 months gap you need to take in conducting again the next test if you want to apply the test retest reliability. So it is very time consuming process. Getting me?
Yes, yes, ma'am, I'm getting you. And you also talked about the split half reliability.
Yeah.
In the split half reliability, uh, can we take two different locations? Suppose we use the sample survey in two different locations. Can that be falling under split half reliability?
I think that I need to check. That I haven't checked. I think location wise it will vary or not. Usually it is mentioned in the books. You need to divide your participants into the two group, and at the same time you need to conduct the test. It is mentioned at the same time you need to conduct. So probability is that if it will be feasible for you, if you are taking the respondents from the same place or same location, and that way you are dividing them in a two parts, and you are circulating your questionnaire or scale to those people, and you are collecting their scores.
Okay. And the last question is that the Cronbach alpha, let us say there are multiple variables and there are sub variables under that. And in case the Cronbach alpha of the variable is very high, over 0.9, but there are components in the under the variable, there are sub factors of the variable in which the Cronbach alpha is falling between 0.7 to 0.9. Then, then again, we have to just look at the variable or the subparts of the variable. Is my question clear?
No, question is not clear.
So suppose I have, let's say, total of 7 variables. 5 are independent, 2 are independent, and 5 are dependent.
Sir, I think you're not getting reliable. In that case, you're not understanding what I'm saying.
Okay.
I'm saying I need to because a dependent independent will come later on, right? According to your hypothesis. Firstly, suppose I want to measure the satisfaction. I'm taking a simple example, right? Suppose we are talking about the online training programs, right? So I want to understand the perception of people towards online training program. Getting me? So your construct is what? The perception of the people towards online training program. So definitely you will ask a question on a same thing you are asking. The voice clarity is there. That is the first statement you are making. The rapport building with the instructor is good in the online trainings. And likewise, you are making certain number of questions. Getting me? Right? So all the questions will be tending towards the one thing. This is what I'm saying. You are asking 7 different variables. I'm talking about a one variable. For one variable, you're asking n number of questions. And that way you are testing the internal consistency in those items. Getting me?
Yeah. So, ma'am, I got that. But okay, maybe I was not able to explain it properly. Let us say that satisfaction is one of the many variables. Let us take that as one. So,
one correction. Right. I mean, now I'm telling you, suppose, as I said, satisfaction is the main variable of mine. Suppose that is the latent variable. So I will identify certain dimensions or factors. I think this is what you are saying.
Yes.
Using the factor analysis, using CF, etc., you are identifying their dimensions. You are identifying their factors. Getting me? This is what you are saying.
Correct.
So that is the let process which you are performing with. That is the letter on process, sir. Presently, you need to only check whatever scale, because all the questions are tending towards to the satisfaction. Maybe they are belonging to the different factor or dimension, but ultimately they are measuring satisfaction. So you need to check the reliability of the complete scale. And after getting that, what the factor analysis, once you are applying the factor analysis on that, if you are getting the proper dimensions, like suppose you have got suppose 6 dimensions of your satisfaction level. So for each dimension, then you can separately calculate or check the reliability.
Yeah, so we are on the same page on that, and I will just say that is my question. So let us say there are 6 dimensions, and the variable is, or maybe the factor is satisfaction, and there are 6 dimensions to it. In the 6 dimensions, the Cronbach alpha is out of the 6, 4 of them are within the range of 0.7 to 0.9. 2 of them are higher than 0.9, and the total of all, the overall satisfaction is over 0.9. So in that case, again, you know what you're talking about needs to be redone, meaning the one which is going beyond 0.9 needs to be relooked at. That is to be done even then?
Sir, first thing is always this will be a call of researcher. But if you are finding, suppose it is a 0.98 for any particular factor or dimension, right?
Suppose it is one or 1.
One meaning is all the questions are identical because it's a correlation. Alpha is nothing, but it is a correlation only. So that is what I'm saying. If you are finding for any of the factor, your Cronbach's alpha value is coming as 1 or maybe 0.99 or something, it is very obvious. In that case, you need to again check your scale. So I think this is the way which, when we are talking about the pilot study is giving us this clue. So using the pilot study, we can understand this thing, whether we are going in a right direction or not.
Okay.
And I think one more thing here I want to say, when we talk about formation of a skill or making of a skill, if you are not using the existing skill, you are making your own skill. So I think it is very obvious. You have referred to the literature review, right? Literature review will always give you a right direction. It will help you to identify the even dimensions also. It is not, because I think whatever researches we are doing nowadays, it is not very new. Somewhere, because we need to do the literature review, so somewhere the things are linked. Previous people have done some work for us, they have already worked for us, and we are having the things available in the literature. So we are identifying the proper variable, and sometimes we are taking the reference of sentences also. So I think we can avoid these things if we are doing a proper literature review.
Okay, thank you, ma'am.
Thank you, sir. Okay, anything else? So shall I proceed?
Yes, ma'am.
Jyoti ma'am, I hope it is fine with you. I think it is very, I'm feeling very bad for you, but I think is time is very limited with us.
No, ma'am, it's okay, ma'am. I will try after the class.
Yeah, I think I'm feeling bad because I know this thing.
No,
People are here to
no, ma'am.
learn.
I understand. Yes.
Yes, thank you so much, ma'am. So I'm sharing my screen again with all of you, and this time I'll share the sheet with all of you, and I'm expecting you to open the sheet which I have already shared with all of you on the WhatsApp group. Have you received it? It is visible, I hope. Shall I start? Have you received?
Yes, ma'am.
Fine. How many of you are doing
I
for
didn't
me?
receive that file. Can you share it once more?
Ma'am, you said it on WhatsApp group. It's not there. Which WhatsApp group?
Of this FDP?
No, ma'am. Okay, yeah. The YouTube thing. It's not sharing.
No, no, no. Above YouTube, sir, you can check it. Let me check.
Ma'am, I have received on the FDP group one about your session, then YouTube live, and then
Today, have you joined Devashish, sir?
no, I have joined yesterday, ma'am.
I think at 4:32 I have shared the sheets.
4:32.
Ma'am, I have joined today. So can you
4:30.
share it again?
I think I am expecting anyone else to please share the sheets. If anyone can share the sheets again.
Diabetes costs, ma'am. That's it.
Yes, yes, yes. Diabetes, diabetes and the customer satisfaction.
Yes, I've seen that.
Yeah. So, sir, will you please share again on our WhatsApp group so that everyone can download?
I've done that.
Okay, I received it.
Thank you so much, sir. Thank you, ma'am. So I'm giving you a few seconds. Please download fast so that we can complete the session on time. Actually, I'm in my institute. I need to leave it. Okay. Meanwhile, you people are opening the sheet. I'm showing you the sheet here. You can see in this sheet, you can go to the variable view. If it is not activated, you can click on this variable view and you can see here. We are having total 31 questions on this particular, this particular sheet. And what are the labels? All the labels are mentioned in this sheet. I will request everyone that thing is that this particular sheet which I have shared with all of you, this is only for the demo purpose, right? You cannot use the same data for your research. This is my humble request. Do not do this thing. This data is only here for the demo purpose. I have shared with all of you, and you can find there is total 121 people's data available. Fine. And remaining information, I think you can check here according to your understanding. I think yesterday we already discussed this variable view, so you can find these things here. With this, I think I'm coming on a data view and we'll discuss how to apply reliability. So I hope you all are ready. Shall I start?
Yes, ma'am, please go ahead.
Fine. Thank you, ma'am. So you can see after opening the sheet, Jyoti ma'am, Poonam ma'am, those who are not having their SPSS presently, I request you all of you, please note down these steps. These steps can help you after today's session. When you are able to download that SPSS, you would be able to see that how you can use how you can apply these steps which I'm discussing today, because sheets you are already having. Fine, everyone?
Okay, ma'am.
Yes, ma'am. Yes, yeah. So I think I'm coming on a sheet. Yes. So here, firstly, I'll tell you where you need to go. You need to go to the analyze. So you can write analyze, go to the analyze. Means likewise, we are making the notes of computers subject that we need to write, go to the analyze, right? Click on select the scale and then reliability. So again, I'm repeating, analyze, scale, and reliability analysis. This is what you need to select from here. Once you have done this, I am expecting you to give me a nod so that I can proceed. It is done.
Yes, ma'am.
Fine. After this, after clicking on this, you would be able to see a dialog box is appearing in front of you. I hope that dialog box is appeared on your screens also. Done?
Yes, ma'am.
Yes,
So you
ma'am.
need to, yes. So at the left hand side, all your variables are listed, right? So you can select all using the control A key, and using this arrow key, you can shift from the left box to the right box, which is items. Shifted.
Yes, ma'am, please.
After shifting your variables here, you can just now you can see the models or the methods which we are using to checking the reliability are listed here. By default, SPSS check the alpha, that is convex alpha. There are certain other methods available like split half, Gutman, parallel, strict parallel, etc. So as I said, for today's session, I am discussing alpha, which is mostly used nowadays. So you need to go with the by default setting. In the statistics, you need to click here at the right side. You can find a button with the name statistics. I'm clicking on this. There I'm selecting the item, select scale if item deleted, under this descriptors for. Done. In the statistics button, under this descriptors for, I'm selecting item, scale if item deleted. Done. Everyone?
Yes, ma'am. Yes, yes.
Fine. Click on the continue. Those who are just listening because of some other reasons, like they are not having spaces and all, you can take a pic also. This picture can also help you to see that which things you need to check. You can take a pic of this. Done. May I click on continue?
Yes, ma'am, please.
Yeah. Then after that, nothing you need to do. You can only click on the OK button to get the output. So once you are clicking on OK, I hope output is visible to everyone now. Once you are okay with this, please say to me whether I need to explain further or not.
Yes, ma'am, please go ahead.
Yeah.
Yeah, it is.
Now we are starting with the first table, which is all variables. There you can find we are having total 121 items and nothing is excluded because no missing value is available there. So that way total items are 121. Now, next table is the reliability statistics, which is giving you the Cronbach's alpha value. It is indicating the Cronbach alpha is 0.672 and number of items were 31. So for 31 questions of the satisfaction scale, we are getting the Cronbach alpha value as 0.672. So we know this thing. This is not acceptable, right? The alpha value should be even at least 0.7 or above this, right? So now further, I think I told you the methods of what I can say improving of your Cronbach alpha, right? So that we will see in this particular output window. So next table is the item statistics. Item statistics means is it is giving you the simple statistics about the items or the questions of your skill. So you can find these are the questions, these are the mean value and standard deviation value. And for total number of items, 121, these mean value and standard deviations were calculated by the Excel, by the SPSS. You can find for the modern equipment, it is coming as 1.49. So if suppose this is the Likert scale question, that modern amenities or equipments are available on a particular restaurant. Suppose this is a this particular what I can say the scale is related to the restaurant, right? So on a 5-point Likert scale, the mean value is coming as 1.49. 1.49 is almost less than 2. And generally, if you are well versed with the Likert scale, we are knowing this thing. 2 is for the disagree kind of thing, right? So modern equipments are or availability of modern equipment at the restaurant, people are disagreeing with this, meaning that the restaurant is having the modern equipment, right? So that way this is the indication or this is the interpretation of these mean values. So according to on a scale of 1 to 5, you can understand the meaning. Further, talking about the next important table, which is the item total statistics. So here you can find at the extreme left all the items are listed. The next column is scale mean if item deleted, means if you are deleting a particular item from the scale, so the total mean will be of the scale will be of 96.74, means if the first question will be deleted from the scale, so the total scale mean will be 96.74. Similarly, total variance if item is deleted will be 147.24. So this way, these two columns will tell you for each and every item, if these items are deleted, so what will be the total mean and what will be the total variance of the scale. Further, corrected item total correlation. So this is the column which I was talking in the slides. You need to see the values of this particular item total correlation. So firstly, I think as you can recall, I said you need to firstly check whether for any item this particular value is coming negative or not, right? So you can go down and you can check for any item it is coming negative or not. So I think you can find for this attentive attitude and for this personalized service, for these two variables, the item total correlation is negative. So for the means with these two items we can remove firstly, and that way we can see whether there is any improvement in item in the Cronbach's alpha or not. I hope here I'm clear to everyone.
What is the column name?
Corrected item total correlation. I think you are also getting the output, sir. You can check in your output you are performing along with me.
Yeah, I'm doing that.
Yeah. So that way I am selecting these two items, that is attentive attitude and personalized service. So how you can do this? You need to go to the analyze, you can go to the scale, you can go to the reliability analysis, and you can identify those two items. So you can check these two items are attentive. I think just a minute. Let me check. Your questions are attentive attitude. I need to check where it is. Anyone who is able to see attentive attitude? I think this is attentive attitude. No.
मैम above
Ma'am, above.
नीचे इसके नीचे नीचे आइए मैम, नीचे आइए, नीचे
Yeah.
बस।
Question number, yes, fine. Thank you so much. Question number 23 and question number 24 related to the attentive attitude and personalized service. These two are selected, and using the arrow key, you need to send back to the previous box. Done? Done? Okay, I think I'm assuming it is done. After sending them back, you need to only click on the OK button to generate the output again. So you can see the output is coming now, and now the happiness, you can see we are happy now because now Cronbach's alpha has improved 0.67 something. It was previously 0.672. From 672, it is coming as 0.701, which is coming in a range now, which is indicating that the Cronbach alpha is like, it is indicating that now the scale is coming in the consistency zone, right? So now you need to see again, you can go down and you can again check this item total correlation. You can find firstly the negative figures. There is no negative figure, right? Now you will find the most small or most what I can say, the smallest figure in the particular column. So whatever is the smallest figure, you can select that, and that way you can drop it. But question comes till what point or till up to what point you will go, right? So I'll say this thing, that is indication is means that way you can improve your Cronbach's alpha, but you need to see one more thing. The thing is that if you are dropping so many items, that way number of items will be reduced, right? And might be possible some item is very important for you and still you are removing it. So that will be the question again a thing, because whatever you are doing, you need to report the things in the research generally. So you need to take a call how many items or up to what items removal you will go. And again, I'll say you can talk to the expert in this particular case. You can talk to the professors in the field. They can help you out to understand this. Although for the 29 for the 29 items, we are getting the Cronbach's alpha as 0.7, which is acceptable. But it's still there is there is a scope. You can drop one or two more items, and that way maybe it is coming little higher. So you this way that will be the call of researcher, how many items he or she wants to drop, because number of items will be lesser in that case. So that is again a thing you need to see. So balance will be set by the researchers according to his or her discretion, because justification will be asked from the researchers. So that thing should be decided by the researcher. So this way you can check the reliability portion using the Cronbach's alpha. So I think this is about the Cronbach's alpha. Now I'm moving with the next portion of the session, which is the normality. So I hope I can start with the normality now.
Yes, ma'am.
Fine. Okay, so I think now I'm showing you my screen for the reliability, for the normality. So reliability, we have seen, we are checking the reliability of a scale, right? Question is now normality. Firstly, why we are checking normality? Because for many of the parametric tests, it is a very basic assumption that your data or your variable should be normally distributed. So we need to check whether the data is normally distributed or not. So question comes, what is this normality? What is this normal distribution? So normal distribution meaning is that this is a very important characteristics usually for a continuous scale variable or for a numeric scale variable. Normality, we are checking for a numeric variable and not for the categorical variable. So you need to see for the normality, there are certain, what I can say, for normality, there are, when we talk about the normal distribution, there are certain characteristics of normal distribution. So you need to see whether for your data, mean value is 0 or not, standard deviation is 1 or not. So that way, these are the certain parameters. But most important parameters of checking the normality are two, which are skewness and the kurtosis. So skewness and kurtosis, we will understand one by one what is skewness, what is kurtosis, and then we will see how we can check skewness and kurtosis. So normality is nothing but it is generally indicating you whether your data is normally distributed or not. Normally distributed or not meaning is what? As we talk about a population, right? So population, we all know population is consisting of everything. Means if I talk about in terms of age, so we know in our population every age people are there, right? So that means you need to see everything should be available, but that should be according to a proper distribution. So for understanding the normality, generally we are plotting our data on a graph, and we can say using the bell-shaped curve. Means when we talk about the normality, we are talking about the normality of the continuous variable. So we can draw that variable on a graph, and generally we are making a histogram. So histogram is showing you the distribution of your data. So on that distribution or on that histogram, we can keep a bell-shaped curve. I think many of you have already seen the bell-shaped curve. So that bell-shaped curve can help you to understand whether the distribution is symmetrical to mean or not. So generally, we are assuming at the middlemost point of the histogram or of the bell-shaped curve, there is a mean of the distribution. So if your data is 50% to the right hand side of the mean and 50% data is left hand side of the mean, so we can say data is symmetrical to mean. But if there is any change in the proportion, that means your data is not symmetrical to the mean. That way your data is known as skewed data. So skewness is nothing but it is a study of asymmetry in the data. Asymmetry meaning is that whether your data is symmetrical to mean or not. So skewness should of or skewness value of your data should be 0, right? If skewness is 0, meaning is that your data is symmetrical to mean. 50% data is left hand side of the mean and 50% data is right hand side of the mean. So that way it is maintaining the proper distribution of the data. That is skewness. Give me a second, I'll show you. Yeah. So you can find here when I talk about this skewness. Now you can see here in this particular graph, you can find when I'm talking about the middlemost graph. So this particular graph is the exact or the perfect graph which is indicating the normal distribution. For this perfect normal distribution curve, you can find this is known as the bell-shaped curve. And as I said, the middle value is generally known as the mean value of the curve. So for normal distribution curve, generally mean is 0 and standard deviation value is 1. Or you can say generally on this particular point, we are saying mean, median and mode, all three are equal, all three are colliding. That means this is the normally distributed data. But when there is the imbalance between these three values, so you can find when mean is less than to the median, median is less than to the mode. That way you can find this. So this is indicating the negatively skewed data. That means your left tail will be higher or greater than to the right tail of the curve. When your right tail is longer than the left tail, that way it is known as the positively skewed data. In this case, your mean value will be higher than the median and median will be higher than to the mode value. So this is indication. This is the indication of the skewness in your data. Now, question comes how to check the normality of your data. So there are two methods, the numerical method and the graphical method. Numerical method is generally skewness and kurtosis can be used to check the normality, or you can use the Kolmogorov-Smirnov test or Shapiro-Wilks test. These are the three numerical methods of testing the normality. In the graphical section, you can find there are three more graphical methods, which are histogram, QQ plot, which is quantile plot, and the box plot. So using three methods, we can ascertain the normality of the data. Now, talking about just the histogram. So I think histogram, I do not need to comment much on the histogram. We all know histogram is very similar to the bar graph. But when in a bar graph, we know each bar is indicating the category of a particular data. And there is generally there is a gap in the bars. But when we talk about the histogram, there is no gap in the bars because it is for the continuous data, right? For continuous data, you are making ranges kind of thing, 0 to 5, 5 to 10. So there will be value can be 0 to 5, meaning value can be 4.2 also, it can be a complete number also. So that way you are maintaining no distance in the bars of the histogram. And the uh, tallness or the size of the bars are indicating that what is the frequency of the particular range or something. So that way it is the histogram. Histogram is can be of various types, although from whatever source I have taken these histograms, there you can find there are certain gaps, but you can assume there is no gap. So you can see when I talk about the upper side left upper side graph, where you can see I'm rotating my mouse, this is indicating this graph is not the symmetrical to the mean graph, means this is indicating there is a asymmetry in the data. This is data is known as skewed data, right? When you will put a bell-shaped curve on this, you can say this thing that the right tail will be longer than the left tail, right? Coming to the upper right side, you can see this particular graph. Here you can find two bars are very, very similar here. That means this is indicating this is the double peaked graph, or this is indicating there are two modes in the graph. The middle most graph is the perfect normal distribution graph, but the remaining two graphs which you can find, if I talk about the lower left side graph, you can find this graph. This is indicating, this is again showing the right skewed data or positively skewed data. But if you are getting a histogram like this where you are unable to comment anything, that means it is indicating that you cannot comment on the normality of your data looking at such kind of histogram. So these are the graphical methods. Using the histogram, you can comment on the normality of your data, right? Sometimes you can find your graphs can be like this also. So that way you need to be very much, what I can say, be having the expertise when we're talking about the graphical methods, because sometimes graphs can mislead also, right? So that will be totally a discretion of the researcher whether which methods he or she is using for interpreting the normality of the variable. QQ plot will be like this. This is a main fitted line, and that way you can see the data points whether they are going through that particular line or not. So the left upper line you can find, which is indicating this is the perfect normal distribution graph, right? This is known as mesokurtic, which is in terms of kurtosis. There are three types of kurtosis: mesokurtic data, there can be the leptokurtic data, and the platykurtic data. Mesokurtic meaning means the normally distributed data, right? But graphs can be like this also. You can find graphs can be like this also. So looking at the shape of these data points, you can comment that the data is left skewed, data is right skewed, likewise. Thickness is generally measured using the kurtosis. So if your graphs are coming like this, that way you can comment on the thickness of the tails or the thinness of the tails, right? So again, I'm repeating the same sentence. For interpreting the graphs, we need to have the expertise in the distribution in the visualizations. So if you are expert in the visualization of the graphs, that way you can use them to comment on the normality of your data. Next one is the box plot. Box plot is having the 5 components. The most middle line is known as the median line. The upper line of the box is known as the quartile, third quartile. The lower line of the box is known as the first quartile. The upper portion of the upper quartile is known as the whisker, right? And the lower portion of the first quartile is known as the lower whisker. These are the two whiskers. And beyond these, if some data points are falling, these are represented by these circles. So this is the indication of the outliers in the data, right? So with the help of box plot, you can also understand the story of the outliers, and you can also understand the normality of your data. Talking about skewness, I have already talked about. Only the thing is that if skewness value is coming positive, it is indicating positively skewed. If it is negative, it is the negatively skewed data. Kurtosis is the thing you can check here, because we know bell-shaped curve can be in any shape, right? The middle one, which one is the black one, is indicating you this is the normal curve, which is the normal distribution curve. But if you are getting the blue curve or you are getting the red curve, that means it is a leptokurtic. Blue one means when the sharpness is more in your curve. This is the leptokurtic. But when your data, when your curve is very flat kind of, it is platykurtic data, right? So looking at these value also, you can comment on the kurtosis, because this is indication of the, because once I talk about this, what I can say, the platykurtic, you can see positive tails, positive value tails, sorry, positive value means this is indicating your tails are very heavy. Heavy meaning is what? There are so many outliers available on the tails of your data. Negative value means the platykurtic. Platykurtic meaning is that these are the thin tails. Thin tails meaning is that there is very less number of data points which are falling on the tails. So leptokurtic is indicating you that there are so many outliers in your data on the tails, because there are so many values which are falling on a tail, right? And in case of the platykurtic data, there will be very less number of observations on the tails. So that is the meaning of the kurtosis. Kurtosis is indicating you about the sharpness of your curve and about the tails of your, or about the outliers or the tails of your curve. So this way, these are the methods. Just a minute, I need to check. Now I have taken note. So this is about the theoretical concept of the normality. Further, we will see how using the SPSS we can check the normality of the data. So I hope it is okay. May I proceed with the normality now?
Yes, ma'am.
Fine. So you need to open now the SPSS file, second file which I have shared with all of you, named as diabetes cause. I hope you people have opened it. Shall I start?
Yes, ma'am.
Yes, ma'am.
Yeah. So as I said, for when we talk about the normality, we need to check the normality of a continuous variable. Here you can find all the listed variables are the continuous in nature. You can see the scale sign, and we know age is numeric variable, glucose, income, cost, etc. All these are the numeric variable. So suppose I want to check the normality of my income variable, right? So how I can check that? For that, you need to go to the analyze. So the persons, those who are maintaining their notes, can write for checking the normality. We are going on a analyze. Then going to the descriptive statistics, you need to select this explore option. This is fine. Fine, everyone.
Yes, ma'am.
So those who have located the option, they can go to the explore dialog box. After that, you can find all the variables of your sheet are at the left hand side. I said I am checking it for the income, which is household income. So you need to select this household variable and shift it to the dependent list box or dependent box. Is it fine?
Yes.
Now click on the statistics. By default, a descriptive is selected. That means it will give you the descriptive statistics of your variable. So this is what we want. So you can press on the continue. Means in the statistics, nothing change, no change you need to make. Go to the plots. In the plots, at the left side, under the box plot, whatever is the selection, we will go with this. In the right side, under the descriptives, you need to deselect the stem and leaf and select the histogram. And then select the normality plots with tests. Done? I hope done.
Yes, ma'am. Yes, yes.
Yeah. After that, you can press on the continue button, and nothing or no other changes you need to make. You can check in the display when you are returning to the previous dialog box. In the display, it is by default both is selected, means it will give you the statistics also, it will give you the plots also. So we will go with both because I think this is the first time we are doing, so we will see all the things here. So you can click on the OK button. I hope I can click on OK.
Yes, ma'am.
After clicking on OK, you would be able to see output is generated by the SPSS for us. In the descriptives, I'll start with the first point. The mean income is 44 lakh 44,969.86. Next is the confidence, 95% confidence interval for mean. So it is lower mean value and the upper mean value. That means if you are taking other sample from the same population, so the chances of the mean income will be falling in this range. That means the mean income will fall in this particular range at the 95% confidence interval. Means you are 95% confident that if you are taking a other sample from the same population, the mean of that income will fall in this particular range. After that, 5% trimmed mean. 5% trimmed meaning is that you are cutting, you are trimming the mean. So 5% from both the side, the higher side and the lower side, when you are removing the values from the higher and lower side, this is the mean value, right? This is the mean income now. Median income is 42.625. That means there are 50% people, those who are drawing the income less than 42.625, and there are 50% people, those who are drawing the income greater than 42,625 rupees, right? Variance, it is nothing but it is indicating you the variability in the income is this. Standard deviation of the income, which is again, standard deviation is indicating the variability from the mean, which is 15,660. Minimum income is 22,600. Maximum income is 98,363. Range, I think we all know range is nothing but it is a difference of maximum value and the minimum value. So this is giving 75,763. Interquartile range is a difference of third quartile and the first quartile, right? If you can recall the box plot, so the main box with this is the that box value, which is 21,587. Skewness is 0.733. So if you can recall, I told you for the normal distribution, the skewness should be 0. So this value is not 0, but where we can say it is nearby 0. So somewhere maybe using the skewness, I can comment that the data is not skewed or not much skewed, right? Although if I will comment on the skewness, I can say it is a positive value. So probably it is little positively skewed data. Kurtosis is again it's a very small figure, which is minus 0.80 minus 0.082, which is again a very small figure. So somewhere it is indicating that probability is that your data is the platykatic data. Income is the platykatic, means there are very less number of outliers in your data, although, but still it is not perfectly normally distributed. Looking at skewness and kurtosis, this is what we can comment. Coming to the main table, which is the tests of normality. So if you can recall, I told you there are two more methods, Kolmogorov-Smirnov and Shapiro-Wilks test. Generally for small samples, we are using Shapiro-Wilks test. Generally the sample size above 1000 or 500 above, we are using Kolmogorov and Smirnov. So here the data size is not that much, so we need to report the Shapiro-Wilks test. The significant value of the Shapiro-Wilks test is 0.000. Significant value meaning is the p-value. So those who are already in a research journey and they have started their journey, they are knowing how to apply the test using Excel, etc. And if they are aware about the concept of p-value or the significant value, so that way they will relate with me. Using the p-value or significant value, generally this p-value you need to compare with your level of significance. So by default, it is 5% in the SPSS. So from 5%, if I am comparing, 5% meaning is 0.05. So this value is less than 0.05. You can say in this case, you need to reject the null hypothesis of your Shapiro-Wilk test. Question comes, what will be the null hypothesis? So if you are making your notes, you can write the null hypothesis for Shapiro-Wilk test. It is variable is normally distributed. Getting me? Variable is normally distributed. Done? Getting me, everyone?
मैम मैंने सेम मेथड किया बट मुझे ये नहीं आया, नॉर्मलिटी वाला बॉक्स नहीं आया.
I think, ma'am, in the plot dialog box, you have not selected that
Just
normal.
a second. Again, I will go to analyze.
Hmm.
Inside analyze descriptive statistic, then explore.
Hmm.
Explore के अंदर household income लिया.
Second button, plots.
अच्छा, then I need to go to plots और plots के अंदर मैम
That normality plots
with test.
with test.
ओके, अगर हिस्टोग्राम चाहिए तो हिस्टोग्राम स्टेम एंड लीफ पे चेक मार्क लगा है.
No, you need to deselect that. That is very older method. You need to select histogram.
Okay, histogram and normality plot with test.
Yes.
Okay, so from here we can prove our hypothesis whether the null or the alternate hypothesis is accepted based on the p-value.
Yes.
So if it is 0.08 is less than the significant value 0.05, so the
Null hypothesis is rejected.
alternate hypothesis is accepted.
So we
Okay.
can say variable that is in household income is not redistributed.
Okay. Yeah, thank you.
Thank you, ma'am. Now you can see next is the histogram where you can find. Looking at the histogram, I think without keeping a bell-shaped curve, we can comment that data is positively skewed data, right? But if you want to keep a histogram, a bell-shaped curve on this histogram, you need to double click on this. Once you will double click on this, you would be on a chart editor. There in a ribbon, you can find the lower ribbon. From the ribbon, you need to select the second last option, which is the show distribution curve, which is coming like the shape is indicating the normal distribution shape, right? You need to select this. Once you are selecting this, dialog box of properties will appear. This is you need to close because by default normal distribution curve is selected. You can close this and you can find in the chart editor this is coming. You need to only close this. You would be able to see the curve on your histogram, which is indicating this is not a normal distributed data. This is skewed data, positively skewed data, because your right tail is longer than your left tail. Or even also you can comment on here. You can see there is a very gap in the x-axis and in this curve, right? That means it is indicating your data is not appropriate or not up to the mark according to the normality. Is it clear?
Okay, even if the hypothesis, alternate hypothesis is accepted, then also our data can be not in a normal form, right? It is left skewed.
I think our null hypothesis was rejected, ma'am.
I'm sorry, null hypothesis was rejected and
So that
alternate
means
accepted.
we are commenting the same. It is not normally distributed data because there was the hypothesis. Null hypothesis was variable is normally distributed.
Okay, got it. Yeah, thank you.
Yeah. Now looking at the QQ plot, you can find the QQ plot is again telling you the same story, which is indicating these data points are not exactly following this line, this fitted line. They should follow the exact fitted line for the normality, but these are not following the line. That means again there is problem with the normality of the variable. Tended normal QQ plot, you do not need to explain or you do not need to report this. You can leave and you can come directly to the box plot. Although box plot is indicating here, you can find the upper whisker is more than to the lower whisker. The size of this is larger than this. That means it is indicating this tail, that is the right tail, will be higher than the left tail, which we have already interpreted from the histogram. But this box plot can also help you to comment on the outliers. You can see there are two circles coming beyond the upper whisker. This is indicating there are outliers available, two outliers. The respondent number 150 income and the respondent number 163's income is an outlier for you. So possibility is that if you are dropping these two, probabilities that maybe it can improve the normality of your data. Getting me?
Yes, yes.
Fine. So, okay, I'll summarize the session on a note that today we discussed reliability and the normality. We have talked about reliability methods today. We have understood the concept of reliability first. We have understood the concept of all the methods and discussed the most important method, that is the internal consistency reliability using convex alpha and applying through the SPSS. And we have interpreted the reliability value. We have seen how to improve reliability, and that is there are certain methods, two methods which I discussed regarding the missing values and regarding the ambiguity in the statement, etc. This is the thing which we can do by our own software. If I talk about, so item total correlation can help you to improve your convex alpha. This is what we have seen in the first agenda, that is reliability. Talking about the last agenda, which was the normality, we have understood the concept of normality. We have seen the methods, that is graphical and numerical. In the graphical method, we have seen histogram, we have seen QQ plot, we have seen box plot. In the numerical methods, we have seen the skewness and kurtosis, and we have seen the Kolmogorov, Smirnov, and the Shapiro-Wilks test. So that way, we have interpreted whether a variable is normally distributed or not. So lastly, the most important thing which you need to keep in your notes or maybe in your mind is that normality we are checking generally for the continuous variable, and reliability we are checking for a complete scale, right? So on this note, I'll wind up the session. Now I'll request you for the questions and answers. If you are having any questions, you can ask.
Ma'am, these sessions, are they recorded? So in case we have to just refer them.
Yeah, sessions are recorded, sir. The RFI YouTube channel available. Probably, I think in the group also, sir has already shared the YouTube links with all of you. So using those links, you can refer the sessions again. Few of the concepts are already available, means not all, means normality reliability I have not uploaded right now, but few of the concepts are available on my YouTube channel also. You can find YouTube channel with the name Dr. Chanchal Jain. Few concepts are available. I'm in a process of uploading others also. So all are not uploaded right now, but some of the concepts are available.
Ma'am, actually, I missed your first part, that is the reliability, due to some engagement in the college. I did with the normalization. I will go through your video or whatever the recording you will be sharing. If there is any doubt, I will ask you tomorrow.
Definitely.
Yeah, but it will be available. Na? I will refer at night. Yeah.
Yeah. Yogra sir, will you please share all the YouTube links with the participants again? Yeah, thank you so much, sir.
Okay,
So
on
please
the
share in the
YouTube
group.
link,
Yeah, sir
on
will
the
share.
YouTube link is immediately.
Yeah, thank you, sir. Yes. Any other questions? No more questions?
One last question I had, ma'am, is that in the reliability, since in the example which you demonstrated, from 31 items it came to 29 items, right? Now, I know you also mentioned that the researches are already done in certain areas. See, post-COVID, new topics have come up. Like, for example, artificial intelligence is new. Many topics have come up which have got no history of the past. And there are limited literature review also available on those topics because various topics are coming up. So, my question in those cases, will the Cronbach alpha rule of over 1 still hold, or can it be looked at with a little bit of moderation? And reduction of number items where the sample size is in any case less, will that be an appropriate way? So I'm saying the choice between Cronbach alpha slightly on the higher side versus reducing the number of items. What should be the call taken?
Over one meaning is that more than one.
Yeah, one or more than.
Sir, I think as I said, its correlation can never be greater than one. It is up to one only. First thing. Second thing, again I'll repeat, because generally this is we all know, because one meaning is that things are identical. When people are understanding with the items, means they are taking the item same. So that means it is a call of the researcher. It is not a call, means it is an indication for the researcher that definitely you need to change your items or you need to remove your items, because people are taking the items as same. That is why the question is coming one. So there is no use of keeping two questions which are very similar for the respondents, right? And second thing which you're talking about, the literature less or availability of the things or literature is very less in context to the topics which are nowadays mostly researched by the people. In such cases, I think our own observations can help us to create the variable, to identify the variables. But after identification of the variables, the statements or formation, whatever you are doing, drafting you are doing, always that you need to be done under the guidance of the people, those who are having the idea that what should be the correct formation of the items or the questions, because with their experience they can make us correct. Sometimes it happens, means even when I write my question, when I make my question, even I need to talk to the many people. It is like you need to take opinion of many, and that we need to decide what will be the correct form of your questionnaire or the questions. So I think this is what I understood from your question. Probably this is the answer of your question. Is it fine, Debasis sir?
Yes, yes, sure. I will think again tonight, and if I have more questions, I will ask you tomorrow.
Definitely. Okay. Anything else? Okay. So I think no more questions. I think I am sensing now. So thank you everyone for listening me patiently and interacting. That is, I think this is a good thing which I am observing in this FDP. In the previous FDPs, it was very less interaction which I have experienced. But in this FDP, I'm experiencing a good interaction. That's good. It is showing your willingness to learn. Thank you so much for the interaction and listening to me patiently. Tomorrow we are meeting for the next session and we'll discuss further. Now I think from tomorrow onwards we will talking about the statistical test. Fine, everyone?
Yes, ma'am. Thank you, ma'am.
Yes, thank you.
Thank you, ma'am. Thank you, everyone. Take care. See you. Meet
Yes, ma'am.